everyone, I'm Swati and welcome back to my series on mechanics. We are learning vectors, and in the last video we did scalar product or dot product, and we're going to continue with scalar product in this lecture, and we'll do some numericals, learn some more concepts, some tips, tricks, and then we'll move to vector product. Not in this lecture, but maybe tomorrow's. So let's begin with that. So in the last video, we have learned about scalar product and we have learned some of its major things. Initially, we did that how a scalar vector has a product between them, how a scalar multiplied with a vector and then a vector with vector, and we learned that when a vector multiplied with vector, we get a scalar, we get a vector, and we learned our scalar product and or dot product because of the symbol dot, and we learned that a dot b is ab cos theta, and it can, as a component, it can be solved as ax bx plus ay by plus az bz, and we define the formula of cos theta as a dot b upon magnitude of a magnitude of b, and we have also learned some cases that a dot b is ab cos theta, and when theta is 0 degree, then a dot b vector has a maximum value. A dot b is maximum in that case, which is equals to ab. If theta is 180 degree, then your a dot b is basically negative of its value, because here cos 0 degree is equals to 1, gives you AB, and here cos 180 degree is equals to minus 1, gives you minus AB. Okay, and at theta is equals to 90 degree, A dot B is 0. That means for the scalar product, if two vectors are mutually perpendicular to each other, you don't get any vector, you get a 0 vector. So here AB cos 90 degree gives you the value of 0. That means there is 0 vector, there is nothing. So it is minimum at 90 degree when they are perpendicular, and if they are perpendicular, you can solve multiple things. Like one question comes like you have a vector as 2i cap minus lambda j cap plus 4k cap, and b vector as I cap minus 3j cap. Okay, find lambda if a and b are perpendicular to each other. Okay, this is one type. So all you need to do, if they are perpendicular to each other, then we know that a dot b is what? 0. And they are given in component wise, so you can multiply the coefficient of ij k cap simultaneously and with sign as well, and make it 0, like 2i plus 1i. So 2 into 1 is 2. It's minus lambda, it's minus 3, then it is plus 3 lambda. It is 4k, there is nothing, it's simply 0. So 3 lambda is equals to minus 2, so lambda comes out to be minus 2 by 3. Okay, sometimes they ask what's the angle and you find that a dot b 0, but for the angle you can use this formula. For the angle, if you want to calculate the angle between the two vectors, use this formula. Cos theta is a dot b upon magnitude of a magnitude of b. Okay, but for perpendicular you can use this, and sometimes it is like a dot b is 0 has 3 conditions basically. First, theta is 90 degree, that means a and b are perpendicular, and the magnitude of a vector can also 0, but magnitude cannot be 0. So that means your that means your a vector is 0 or b vector is 0. So either theta is 90 degree or a vector 0 or b vector 0. Okay, so any condition, any 2 condition or all 3 conditions. So these 3 possibilities gives you a dot b is equals to 0, but it is not like always that a dot b is 0 then theta is 90 degree, means they are perpendicular. No, it can also be possible that a and A or B vector have the zero thing. Okay. And so yeah, so this is the thing. Now if you use, I am giving you two tips to calculate the angle cos theta. You can use the formula of A dot B over magnitude of A into magnitude of B. Okay, A dot B can be calculated as AX BX plus AY BY plus AZ BZ, and the magnitude can be calculated as AX square plus AY square plus AZ square, and this can be calculated BX square plus by square plus bz square. We have already done one question on this to calculate cos theta in our last video. So this is the basic formula to calculate the cos theta. Now there is a tip. First, if magnitude of a plus b vector is equal to the magnitude of a minus b vector, you have to remember, then angle between A and B is 90 degree. Just remember this thing. Okay. How we can prove that? This is for your competitive thing. But we can prove that. Always remember, for these type of things, that A plus B magnitude is equals to this, all you can do is square both the side. Squaring. You can solve many questions based on this thing. We'll do in this video only by squaring both the sides. So this basically become A plus B dot product of A plus B, because I have already we have discussed this thing in our last video, that if two that means A dot A, if both the vectors are same, then it's simply the magnitude of that square. So if is the magnitude of square, that means A plus B has a dot product with A plus B. Then A minus B has a dot product of A minus B. And then you can use here the distributive thing. It is distributive. We're going to learn that. So dot product with A dot A, then plus A dot B. Okay. Actually, before this, we should learn its true properties. It's commutative and it's distributive, and then we can move to this tip. Okay, trick. So there are two properties. First is commutative law. Okay, the scalar product is commutative. That is, A dot B is equals to B dot A. And it is very obvious. See, if you check this physical interpretation, that is, this is your A vector, this is your B vector, and your B vector is making projection on A vector, which is B cos theta, and then it is a multiplication of A B cos theta. Similarly, A can have a projection here. So this becomes B A cos theta. So it is one and the same thing. So you can write this as A B cos theta, and this is right as B A cos theta. So if you see that A B are scalar, they are the numbers, they are the magnitude. So either you multiply 2 into 3, let's say, yeah, 3 into 2, it's one and the same thing, and then you can multiply it by cos theta. Okay. Okay, my pencil. So 2 into 3 or 3 into 2 and then multiply with this cos theta, it remains same. So that means A dot B is equals to B dot A. Okay. And if you check by component wise, then it is your AX BX plus AY BY plus AZ BZ, which is equals to what? BX AX. And now these are the numbers. They are the scalar numbers. They are the coefficient of ij cap. So if you multiply AB or BA, it's one and the same thing. So they are commutative in nature. First thing, A dot B vector is equals to B dot A vector. The first property is this. Second property is it's distributive. Distributive law, which you have learned in maths. It's same here also. Like A dot B plus C is equals to A dot B plus A dot C. Okay, it's same thing. You can also check this by a question, or again, it's a physical interpretation. Means you add two vectors and then take the projection on A, or you take individual projection on A and then plus. It's one and the same thing. Okay, so this is the thing. And if you want to know it with an example, so let's take A vector to be I cap plus j cap, B vector to be j cap plus k cap, and C vector to be I cap minus j cap plus k cap. Okay, I'm proving this thing. So for first, A dot B plus C is what? You have to add B and C and then take a dot product with A. So A is I cap plus j cap, and you want a dot product of B plus C. So B is what? J plus K, and C is what? Plus I cap minus j cap plus k cap. Just take a dot product. First solve this thing. So there is no I, so it's simply I cap. This is j minus j, they cancel. It's k plus k, it's 2k cap. Now it's I, 1 into 1 is 1. There is no j, so here you take as 0 j cap. So it's 0. There is no k, here is k. So basically you have to write it in all three components. Okay. And here also, and then if it is there is no component, like there is no k component, so you have to write it as 0 k cap. There is no j component, so you have to write as 0 j cap and then multiply that. 1 into 1 is 1, 1 into 0 is 0, 0 into 2 is 0, so answer is 1, like that. And then it's A dot B and A dot C. So first calculate A dot B vector. So for A dot B is I cap plus j cap dot B vector, which is j cap plus k cap. Okay. Again, there is I, there is no I, 0. J and j is 1. There is no k, 0. So it is 1. And then A dot C. So A is I plus j and C is I minus j plus k. I minus j plus k cap. So I is 1 plus j minus j is minus 1. There is no k, so it's 0. So eventually it's 0. So if you add A plus B, A dot B and A dot C, you'll get 1 plus 0, that is 1. So it's distributive. It's very basic. Okay. So now let's move to the tip, which is important. The tip was A plus B is equals to magnitude of A minus B, then theta between A and B is 90 degree. You can remember that, and I can show you its proof. Okay, just remember that for your competitive exam. You just have to mark a tick, but will prove, because I think if you're going to continue your career in science, you should know the basics, you should know the concepts. So it's very important. And if you are good with your concepts, you can achieve anything. Okay, now again there's a tip. In this tip, whenever you have to deal with this A plus B and minus B magnitude, always square them and you will achieve whatever you want. Okay, I square both the side, and if I'm squaring both the side, then I can write it as A plus B dot A plus B, because we have already discussed that if you take a dot product of a vector with itself, if you take a dot product of a vector with itself, it's basically its magnitude square, because theta is always 0. One vector over one vector, angle is 0 degree. It's always in the same direction. Is equals to a minus b dot product of a minus b. Okay, so this gives you a dot a plus a dot b plus, again a dot a is okay, then b dot a plus b dot b. This a dot a and b dot b can be written as magnitude of a whole square, like this, magnitude of b whole square. Now it's minus, so I'm using distributive property here, minus a dot b, again minus b dot a, and then plus b dot b vector. Okay, now this a dot a can be written as what? Magnitude of a square. A dot b, b dot a. B dot a can be written as a dot b because they are commutative. So a dot b become twice of a dot b. Right, because this can be written as a dot b as per commutative, which we have discussed earlier. And this become magnitude of b whole square. And now magnitude of a is a scalar thing. Here also it's magnitude of a square. This become minus a dot b minus a dot b minus 2 a dot b, and this become magnitude of b square. Now this term and this term cancel each other. This is a simple maths. And if you take this here, this become 2 a dot b plus twice of a dot b. Take both and is equals to 0. Take both together, it becomes 4 dot a dot b, or you can simply say a dot b equals to 0. Now if a vector is not equals to 0, means you have some a vector, you have some b vector, then definitely theta should be 90 degree. Okay, so if this is the condition, where a vector is non-zero, it's not a zero vector, and b vector is also not a zero vector, then the angle between them is definitely 90 degrees. So this is a tip. And the second tip is, if simple a plus b has a dot product with a minus b, equals to 0, if this is the condition, then a vector and b vector are equal in magnitude. So this is the tip number 2, which you can remember for your MCQ type thing. Okay, so for this, if we check the proof, we already have a dot product, so you don't need to square it. You can simply start with distributive property, a plus b vector dot product of a minus b vector, and that is equals to 0. So take a dot product, that is a dot a, then minus a dot b, then plus b dot a, and you can see this plus minus a dot b and plus b dot a cancel each other, then minus b dot b equals to 0. So if you use the commutative property, these two cancel each other, and then it simply become magnitude of a square minus magnitude of b square equals to 0. And if you take 1 there, you will get that magnitude of a is equals to magnitude of b. It's lagging. So your magnitude of a become equals to magnitude of b. So that's the second tip. Just remember these two tips, which is essential. Next, third is, if theta is, let's say, acute, your a dot b is something positive. Now this can be helpful while calculating like work. Work is a dot product of force and displacement. So as per the theta angle, you can say that the work is positive or negative. You have already learned that. And if theta is obtuse, then A dot B is negative. So you have learned that thing in work done. So in vectors it is this, and yeah, work done is basically the dot product of force into displacement, F dot S, which is Fs cos theta, and as per the value of theta, it can be positive, negative, and zero. And by physically, you think that if displacement is positive, displacement is zero, displacement is negative, the work done is positive, negative, and zero. But work done is a scalar quantity, but it can be positive, negative, and zero. Okay, so these are some of the things. Now, again, which we are discussing, that squaring thing, you have one more numericals which you can see at many places. So we'll do some numericals on that, which is very common. And yeah, let's say, let's consider three vectors A, B, and C such that A equals to B plus C. Okay, and their magnitudes are 5, 4, 3 respectively. Find the angle between A and C. Find the angle between A and C. Okay, so now you have given the condition that A is equals to B plus C, and you have also given the magnitude, and you have to find the angle between A and C. Now, whatever the vectors are, you have to take them together. Like here it is A equals to B plus C, but you have to find the angle between A and C. So you have to take A and C together. So first of all, B vector become A minus C. And then you have to square it. That is the basic technique, basic method for this. Okay. If they ask between B and C, then you can continue with this. If they ask between A and B, then you have to use A minus B equals to C. So first is this. Then you can square them. It simply become B dot B vector, or that become A minus C dot A minus C. Okay, I'm already taking that dot thing, A minus C. Okay, and then you can use distributive property. This can be written as magnitude of B square. And now this become A dot A, which become magnitude of A square. I'm writing it directly. Then it become minus A dot C. Then it become minus C dot A. Then become plus magnitude of C square. Okay, I'm doing it directly. Now B has a magnitude of what? 4. Then it becomes 16. A has a magnitude of 5, which is 25. Minus, not C dot A can be written as A dot C, then becomes twice of A dot C vector. Okay, and C has a magnitude of 3, so it becomes 9. So first is 16. Let's take this term here. 16 minus 25 minus 9 is equals to minus twice of A dot C. Okay, and if you solve this, then 16 minus 25 gives you minus 9, and it's minus 18, which is minus 2, and A dot C can be written as magnitude of A, magnitude of C, cos theta. A C cos theta, and you can write it as 9. Magnitude of A is 5. C is 3 cos theta. So basically cos theta become 3 by 5. Okay, 3 ones are 3 threes are 9. So it's simply 3 by 5. So theta is cos inverse of 3 by 5. Okay, so this is something which is very common and you can see this at many places. Next is, let's say you have force of I cap plus 3j cap minus k cap, and displace, okay, let's take, and distance, and covers, let's say an object gets a force of this and covers a distance of 5 kilometer along z-axis. Find work. Find work. Okay. So work done is basically what? Force into displacement. Now here the distance is 5 kilometer, but along z-axis, so you can write as 5k cap. But only this is the concept. 3j cap minus k cap dot 5k cap. Now here is only k cap, no I and j, so you have to use these two terms only. Minus 1 into 5, that is minus 5 joules or Newton per. It is kilometer, you can change into meter, but you have to change. Let's take this as meter. I just want to tell you the concepts, but you can change that in meter because meter is as a unit. So this is the thing. Now this is all for today's video, but tomorrow I think I'll do some more numericals on this. We'll see, or we can start with vector product, or we can do both. So meet you tomorrow with, let's say, something interesting. And until then, thank you for watching this video. Do like, share, and you can comment all your questions, all your queries there, and I can come up on Saturday or to solve all those queries. Any topic, any question, anything you want to know, you want to understand, you can just comment below and we can discuss that on Saturdays. And you can share the videos with your fellow mates, whoever wants to learn vectors. And then we'll continue with mechanics, the kinematics part, and everything there in mechanics. So subscribe the channel so you don't miss the videos, which I'll try to post from Monday to Thursday, but sometimes the things not in favor, but I try to post from Monday to Thursday. And yeah, share, subscribe, and do like, and thank you so much for watching the video.